So here we go. Today we're going to talk about a couple of area formulas for triangles. These are just nice to have depending upon what facts you know about a triangle. Probably every triangle you ever work with now, you do 1/2 base times height, right? Which is nice. If it's a right triangle, it's really nice, but sometimes it's kind of a pain, or you have to solve for a height, or you have to measure some things. You have different things like that. Today we'll have two different options on how to do this. The first is called Heron's formula. It works for any triangle. It's really handy, and it really works best. Well, it works best when we're given the three side lengths, right? So if you know the three side lengths of a triangle, this will give us the area without having to know which is the base, which is the height, having to know any angles or anything. To derive this, it's just a consequence of the law of cosines. It's kind of a tricky, just algebraic derivation. I can show you if you want, but I'm not going to take the time to do that today. Our second one I can show you real quick where it comes from, but this one's kind of a pain. And what we do with this is we use this measurement called the semi-perimeter, which we know the perimeter is you just add up all three sides. The semi-perimeter is you add up all three sides and divide by 2. Not a whole lot to it. So that would be A. Well, actually what we know here is we know at little a, little c, and little b. So if you do A plus B plus C divided by 2, that gives you S, which we call the semi-perimeter. Just take the perimeter cut in half. And then the area of the triangle is going to be the square root of S times S minus A times S minus B times S minus C. Okay. So again, the semi-perimeter minus one side, semi-perimeter minus the second side, times the semi-perimeter minus the third side. Okay, so that's going to be this formula. That's called Heron's formula. Okay. Works out pretty nicely. Right? Works out really nice. So maybe let's jump to the first example here on our note sheet. And with this example, we're told to find the area of triangle ABC. Okay, so for our first example from the note sheet here, we're given the triangle ABC. We have sides of 2, 3, and 4. Again, make sure your two shorter sides add up to be greater than the larger side. It's just sort of basic triangle stuff. So then with this, the first thing we'll want to do is find the semi-perimeter. So the semi-perimeter is going to be 4 plus 2 plus 3 divided by 2, which will give us 4.5. Add them up, divide by 2. So then our area, we're just going to apply this formula, right? So it's going to be the square root of 4.5 times 4.5 minus 4, 4.5 minus 2, times 4.5 minus 3. It's kind of just something you type in your calculator, right? Just make sure you type it in correctly. I might go ahead and take a second to try that, but you should get that our area then is about 2.90 units squared. Now, not that we need to do it, but just so I have an idea of why this is so useful, is if you were given this triangle and you were asked to just find the area of this triangle and you were going to use base times height, what we'd have to do is we'd have to draw the height in here somehow. Let's see. Maybe you'd call that the height. And then we'd have to maybe find this angle over here, right? We'd have to use law of cosines to find this angle. Once you do that, you could use a sine function to find this height. Then you could do 1/2 3 times the height, and it would also give you this. But this is just a lot quicker, right? It's really quick. And I like it too. It's really, I always think of like, when might you use this? Well, maybe you're trying to figure out, the area of a field for, I don't know, putting down fertilizer or something. You can just measure the three sides, apply the formula, and you're good to go. if you like to program formulas in your calculator, it's a pretty easy one to get the whole process. We'll try that at some point. Okay, our next area formula, again, I don't know of a name for it, it's just a nice formula. This is the one you want to use if you're given two sides in the included angle, right? So we know the two sides form an angle. If you know that angle in there, again, this would look like a law of cosine's case, but you get this really nice formula. And there's three versions of it depending upon which angle you know. Sometimes I actually see this written as 1/2 AB sine theta, where theta is just the included angle. This is how I have it written out here. This is how our textbook does it. So if we know sides A and B and angle C, the area is just going to be 1/2 A times B times angle C, times the sine of angle C. Sorry, that's kind of important there, right? If you know A and C and then angle B, it's 1/2 A times C times the sine of B. And then the last one is if you know sides B and C and angle A. Oh, this should be an A, right? What did I do? I wrote the same version twice. This should be AB, nope, should be AB, and then C. Sorry. So notice you'll have a side, and then the included angle. So this one was AB sine C. In this one, we actually can verify this really quickly. It's pretty straightforward. So I'll show you that. I just have this sort of generic looking triangle here. It's nicer if it's a acute triangle, just to make it a little bit easier to look at. But I know that if I were going to find this area, and I didn't know, oh, I did write it the same, didn't I? I'm having all kinds of trouble. So there's A and B, so it's BCA. Thank you. Sorry. Sometimes too, again, our old textbook said 1/2 AB sine of theta, where you just said theta is the included angle, A and B are the sides that make the angle. So you could think of it that way too. I like to think of it that way better, but they're all true. But so if we look at this picture here to kind of verify this, we have this triangle, and I just went ahead and arbitrarily picked one of the heights, right, depending on how you look at it. So in this case, as we're looking at this, our base would be B, correct? Our height would be H. But we know A and C and B, correct? Let's say that we're given those three pieces, right, just to kind of verify this. Well, again, we know our area is just going to be 1/2 base times height, but we don't know the height yet. But if we do know this angle C, right, and we know this side A, can we find H? Sure, because with that, we know the sine of angle C is H over A. And then, so then the height would be A times the sine of C. And if you plug that in for the height right there, right, you get the area is 1/2 B times A sine of C, which gives us this first version right here. So really that's all that is. It's just a shortcut, right? But that's where it comes from. That's the proof of it, is how, if you were given just a side angle side, that's how you'd have to find the area. But we don't have to do that because we have these formulas, right? We have this, whatever this area formula is called. We don't have a name for it. So let's look at an example. All right, for our second example, we're asked to find the area of triangle ABC. We're told that side A is 41, side B is 44, and side C is 42. Now I could look and see that that does fit one of the formulas, but I still kind of think about this included angle definition. So I'm just going to draw a quick little picture here. Label it A, B, C. And then we have here is 41, here is 44, here is 42 degrees. So we see that we have two sides in the included angle. We also see our first form of this was 1/2 AB sine C, which it fits in there exactly. So the easiest way to find this area is we're just going to do the area is 1/2 A times B times the sine of C. So you'll have whatever letters you use for the two sides, you'll use the third letter for the angle. Way to look at it too. So then here, area is 1/2 41, 44, sine of 42. And we go ahead and multiply that out, and we get 603.6 units squared. Is that good? So pretty easy, right? I mean, these are shortcut formulas. They're not. They're just things that can make your life a little bit easier. So, very good. Let's go ahead and look at this third example, and I'll maybe have you give it a shot here before we move on. So for this third example, we're given a triangle with a perimeter of 16 and C equals 3 and B equals 7. What is the area? So take a second and try that, and then we'll come back together and look at it. Okay, so with this, well, we know two side lengths, and we know the perimeter. Well, we know if you add three sides up, you get the perimeter, right? So what we're going to find here is that 16 is A plus B plus C. So 16 is A plus 7 plus 3. And A is equal to 6. Okay, now the semi-perimeter, what would it be? It's half of 16, right? That's all we have to do. So in this case, because we were given side, 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 we want to use Heron's formula. It's going to be the easiest by far. So we have that the semi-perimeter is 16 over 2, which is 8. The area, the formula, again, I like to write these out until I know them by heart. Just use them each time. So it's semi-perimeter minus A, S minus B, S minus C, all multiplied together. So in this case, we get 8, 8 minus 6, 8 minus 7, 8 minus 3. When they're small like this, you could actually probably find an exact answer if you wanted to. But I just went ahead and typed it in my calculator, and I got this would be 8.9 units. I just put units squared. It's kind of a nice touch if you're doing areas. It wouldn't. If you were given like that each side was feet, then you would definitely need square feet. In this case, if you didn't have units squared, it's not a huge deal, but it is a nice thing to just kind of think about your units as you go through that. Any questions with that? No? All right, we're all set then.